Hello, class. The last transformation we're going to talk about in this chapter is translations. All right, we talked about translations a little bit in the first section. All a translation is, it's just moving a figure without rotating or reflecting it. Okay, so it's just a slide. So it's just picking up something, okay, that triangle, and sliding it over here. And so it's got the exact same shape, same size, doesn't rotate, doesn't reflect, nothing like that. It's the exact same shape. Nothing changes. Just moves. Okay. Theorem, very clearly. Translation is an isometry, doesn't change. Like I said, this pre-image and this image are congruent, have to be the same in order for it to be a translation. Now, double reflection is a translation theorem. Okay, so this is one of those more difficult things for you to understand, so pay attention to this example. So if you have a figure, let's just say do a line segment because they're the easiest to see. All right, and you reflect it twice, okay, over two lines. But unlike the last double reflection theorem that we had, where the two lines were intersecting, these two lines are going to be parallel. Okay, so we're going to draw one line, and then another line over here. Okay, now those two lines have to be parallel. Okay, if they're parallel to each other, remember, parallel, 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 very important, gotta be parallel. Okay, so reflect it once. You got AB here. To reflect it, remember, you got to get to this distance. It's got to be at a perpendicular to the same distance the other side. That's about right. Okay, so that'll be B prime. These have to be the same. And same thing for A. Good. Like that. That would be A prime. Okay, let me change the color because you can see it a little better. Okay, so that's A prime, B prime right there. First reflection. Okay, now we're going to take that A prime, B prime, reflect it over the next parallel line. So in order to do that, do the same thing. Reflect it. These have to be the same. That'd be A double prime. And same for B. And there's B double prime. Okay, connect those, and we see that if you do this double reflection over parallel lines, your final result from beginning to end is just a translation. Okay, so you're just picking this up, not moving it, rotating it all, and sliding it over. Okay, now the distance between these two, this distance between the slide, so look here in purple, this slide here, that distance is twice the distance between the two parallel lines. So if the distance between the two parallel lines is x, then the distance between the translation is 2x. Hope that helps. Okay, so we're going to sketch. We're going to sketch a parallelogram. All right, so we got R, -4, -1, -2, 0, -1, -1, +3, and -3, 2. Okay, so we have this parallelogram here. All right, we're going to move the whole parallelogram. We got R, S, T, U. All right, now to draw the image of this, it's just going to slide. Okay, we're going to use this translation. Add 4 to all the x's, subtract 2 from all the y's. Okay, so to move R, we have to move to the right 4. 1, 2, 3, 4. Okay, and down 2. 1, 2. So we're going to end up right here. That will be R prime. Okay, you can do it to the other ones too. For S, move right 4. 1, 2, 3, 4. Down 2. Here's the result, S prime. T is the same way, to the right 4, down 2, and it'll be at 3, 1. And lastly with U, it'll be at 1, 0. And there's the new translation. Okay, so For this, obviously it's pretty simple because all you have to do is move without any rotating or reflecting. Number 2, we have a triangle. Triangle XYZ, so x is at -7, -2 over here. Y is at -4, 1. Z is at -5, 4. Alright, so there's our pre-image. First we're going to reflect that. We're going to reflect it over 2 lines. The first one, line K, is at x equals -2. That line right there. There's K. Then we're going to reflect it again over x equals 3. Okay? To see what our final translation looks like. We'll start with this first reflection. Alright? Takes 3 to get to that first line. So you got to go 3 after that. 1, 2, 3. There's Z prime. Okay, Y takes 2 to get there. So 2 more. There's Y prime. And X takes 1, 2, 3, 4, 5 to get there. So 1, 2, 3, 4, 5. And there is X prime. Okay, there's the first reflection. Now, second reflection. We'll do the second reflection in purple. Do it again for Z. Takes 2 to get there. Do 2 more. There's Z double prime. Y, we have 1, 2, 3 to get there. 3 more. Y double prime. X is on the line, so you keep it on the line, and that's X double prime. Finish it up. And what is this overall translation? If you look, transformation, sorry. If you look at the start to finish, what's happening? You're sliding it over. Well, how far are you sliding it? Remember I said the slide is, you could count, obviously, but the slide is twice the distance between the 2 lines. So what's the distance between the line at 3 and the line at -2? The distance between those 2 is 5. So twice of that is 10. So the translation is 10 to the right. That's the answer. Last example. Okay, we're just going to move one vertex. Okay, we're going to start with vertex A, -3, 0. And we're going to move it to 5, 3. The question is, what is the translation? Okay, so we're moving here and there, right? What's the translation? Well, we do this, right? We have this xy becomes x plus or minus what? Well, we're moving to the right. 1, 2, 3, 4, 5, 6, 7, 8. So x plus 8. And what about the y? What do you do with the y? You're going up 3. Y plus 3. That's all I'm looking for a problem like that, is to draw the translation. Alright guys, that's it for chapter 7.